Okay, with operations with scientific notation, we've learned that whenever you are adding or subtracting, the exponents have to be the same. So I'm going to kind of circle these two, and I'm just going to write myself a note. Exponents must be the same. Okay, so I'm going to switch colors here to blue. I'm going to go ahead and take care of these two problems first because they're multiplication and division, which are always easy peasy, just in the sense that multiplication and division are not snobby. They like whoever. They'll go with whoever. They don't have to have the same exponent. You just do the math. All right, so since this is multiplication, I'm going to multiply 8 times 4. 8 times 4 is 32. Then I'm going to multiply 10 to the second times 10 to the third. Well, we've learned over the course of the last few months that when we multiply with the same base, like 10, we do what with the exponents? We add them. So 2 plus 3 is 5. So this is our answer. The only problem with it is it's not in scientific notation because remember, this first number has to be between 1 and 10. And right now it's not. It's 32. So what do we need to do? We need to move the decimal so that it is between 1 and 10. So instead of 32, we're going to make it a little bit smaller, and we're going to make it 3.2. So since we made this number smaller, meaning we took one step back, we need to make this exponent larger, or we need to make it one step forward. So I'm going to let you figure that out. What should this exponent be? Coming down here, same thing. We have 8, and now this time we're dividing by 4. 8 divided by 4 is 2. Then we have our 10 to what power? Well, we learned that when we divide, we subtract the exponents. Remember, the order always matters. Whenever you're subtracting, you can't just flip the signs around or flip the numbers around. It is 2 as my exponent minus 3 as my exponent. Leave, change, opposite, and you will get what as your exponent? It isn't 1. And that kind of reminds me for E, which I did not put up here, you were supposed to pick one of these problems and prove it with scientific notation converted to standard form. So let's just do that here. So 8 times 10 to the second power is 800, right? Because we moved the decimal over twice. Then we divide that by 4 times 10 to the third power. So that's 4 and then 3 zeros because I moved the decimal 3 times. So that's 800 divided by 4,000. Now you could set up a house if you wanted to. First number gets stuck inside, last number gets stuck outside. You could do that if you wanted to. It's actually not so bad because I would just add a 0 and 4,000 goes into 8,000 2 times. So whatever my answer is here, it should be the same thing as 0.2. Well, if you put that into scientific notation, we would need to move the decimal up 1, which means we need to move the exponent back 1. So that's how that E problem was supposed to help you, because you were proving that you were right. Okay, now we come to the addition and subtraction where we have to have the exponents as the same. It doesn't really matter which one you change. You could change the 10 to the second to become 10 to the third, or you could change 10 to the third to become 10 to the second. I like to make the smaller number one bigger because it just, in the long run, requires less work. Okay, so let's change this bad boy here into 10 to the third. So obviously I went one step forward in my exponent from 2 to 3. That means I need to go one step backwards in my number. So I'm going to move it back 1 and I'm going to get 0.8. times 10 to the third. Okay, now I'm in business. Now I can add because now they have the same exponents. So I have 0.8 right here, and I'm adding 4. Well, 4 plus 0.8 is, of course, 4.8. Okay? And then our exponent does not change. The only time exponents change are when we're multiplying or dividing. And so I will let you figure that out. We do the same thing here. We're probably going to want to take our smaller exponent and make it into our larger one. And so it's the same thing as what we just did. We'll bump that decimal back. So this is 0.8 times 10 to the third. Okay, so now I am subtracting. So I'm going to subtract 4 minus 0.8. So this time, instead, oh, I think I have a little eraser here. I can erase all this. Isn't that cool? I love it. All right, so now I'm just going to subtract. Well, I can't subtract. I need to add a 0, and I'm going to have to borrow, but you're not going to get 3.92. I'll tell you that. Some people did that because that's what we had in the bell ringer, I think. All right, so hopefully that helps you with this one.